So the brainstorm I had about what Dr. Stevens is doing with this. So really this is just like what we did earlier in chapter 5. At the end of chapter 5 is we said, okay, we can use z-scores. We know as the sample size gets larger and larger, that this binomial distribution approaches a normal distribution. And so he's just having us talk about, so how do samples vary when you're dealing with proportions, with categorical variables, really. So I did this off screen here where I calculated the mean and the standard deviation for this problem, which I haven't looked at the answers in the back of the book, but I'm pretty sure this is probably what he's doing, because it follows along with his method. And so then I said, so as a sample, it's getting a sample in a sample of 220 employees, is getting a sample of 85 that are satisfied, an unusual number. So I calculated the mean and the standard deviation. I threw in this normal curve applet where I used the mean and I used the standard deviation. And then I said below 85, and notice it's way down here in the left end. Of course, he kind of tells us in the problem that it's pretty different. So it's way down here, so the chance of that happening is pretty small. So that calls into question is, and this is where we're going to investigate it when we start doing significance tests. That calls into question this poll result of 48%. Probably was a bad sample, is what we suspect, but you know, we don't know without further study. So that's Dr. Stevens' method. Now I'd like to show you how that corresponds to what I showed you, and then what most of the rest of the world does, and what we're going to do in chapter 7 and 8. So when you're dealing, typically what you do when you're dealing with categorical variables like this, you talk about its proportions, and instead of counts we do rates. And so what we'll do is we look at the 48% as being the mean. That's the middle of this distribution. And then to get the standard deviation, oh, you can't quite see that. To get the standard deviation, you do the p times the q, 1 minus p, then divide that by the sample size, then you take the square root, and that's what I got for a standard deviation here. So here's the center of this distribution. I'll do a rough picture, then we'll look at a better picture. So instead of having 105.6 as the center, we're going to say 48% is the center. And here's our p hat. P hat is this. This is the population proportion. This is the result from the sample. So it's the statistic. It's the population. It's the sample proportion, p hat. So we're trying to say, is that sample proportion of 0.386 unusual? Is that far enough away from the 0.48 to say something's going on? Looking at the other technique, we knew it was. Now we're going to use this technique. So I grabbed that David Lane applet. I threw in the center of 48. Notice that's the center. And here's the standard deviations. And here's the sample sample proportion, which is way down here. And look, it's the exact same probability. So it's just a matter of dealing with counts or dealing with proportions. And where we're going with this is proportions. So that's why I showed you that in my walkthroughs. Okay? So I had a brainstorm today, and an aha moment today with what he's doing. So I hope that helps.